morning, dear students. Today we are going to start our lesson 10, circles. You have learned in class 9 about a circle. What is meant by a circle? The collection of all points in a plane which are at a fixed distance from a fixed point is called a circle. The collection of all points from at a distance from a fixed point. That means this is the center. That fixed point is the center, and the collection of that all points make the circle. So this fixed point is the center of the circle, and the fixed distance is the radius. We represent the radius with the small letter r. So r is the radius of the circle. Then other things about circles you know already learned in class 9: segment, sector, arc, diameter, etc. First is the chord. Chord means 2 points on the circle joined together, we get a chord. Then the longest chord of the circle pass through the center is called the diameter of the circle. Then segment. Segment means the region between the chord and the arc. This region or this region. The chord and the arc. Either arc, any arc. This arc or this arc. This is a segment and this is also another segment. Next is a sector. Sector means the area between 2 radii and the corresponding arc. Then this is one sector and the other sector is this one. This is 2 radii and this is one arc. So this is one sector, and the same way this is 2 radii and this is the arc. The between region is also a sector. You learned in class 9 about major sector, minor sector, major segment, minor segment, then major arc, minor arc, etc. Long one arc is major arc and the shorter arc is the minor arc. And major sector, that means the long one arc with 2 radii. This portion is major sector and this portion is minor sector. The same way, this is the minor segment and this is the major segment. These all things are you already learned in class 9. Please recall it. Now consider one circle and one line passing here. Here is one circle and here is a line. Line name is PQ. So what is the connection between this circle and the line? This circle and the line have no common point. No common point. No common point. No common point means they are not touch and they are separate in the plane. So this is called non-intersecting line with respect to circle. This line is known as non-intersecting line with respect to circle. Now we are saying with related to circle. Okay, so this is non-intersecting line with respect to circle. Now look this figure. What is the speciality of this line and the circle? Any relation? Yes, there is a relation. There is 2 common points for line and circle. That is point A and point B are common for circle and this line PQ. So line PQ is secant of the circle. So it is called or it is saying that line PQ is a secant. Not that word. Secant of the circle because both of them have 2 common points. Now another figure. Listen carefully or look carefully. Observe it. What is the speciality? Here one common point for both the circle and the line PQ. That common point is A. So this circle and this line PQ have a common point A. So line PQ a tangent to the circle. So it is we can say that this line PQ is a tangent to the circle. A tangent to a circle is a line that intersects the circle at only one point. A tangent to the circle intersects circle with only one point. Okay. Now look this figure. Here so many lines are passing through one point. So many lines are passing through one point. Now observe carefully in your textbook page 207 figure 10.3. Observe carefully. Here there is only one tangent at a point of the circle. Here only one tangent. All others are passing through two lines on the circle. So there is only one tangent at a point of the circle. All others are passing through 2 points on the circle. These all lines are secant to the circle. Okay. Now in your textbook page 207, last sentence, listen carefully. The tangent to a circle is a special case of a secant. Secant means line like this, passing through 2 points. So the circle and the line have 2 common points. So the line is secant of the circle. So the tangent of a circle is a special case of secant when 2 points of its corresponding chord intersect chord coincide. That means these 2 points coincide here. This is a special case of secant. Tangent is a special case of secant. That means these 2 points coincide here. So this is a special case of secant. The point of this is common point for the tangent and the circle, or this line and the circle. So this line is the tangent of the circle. Then this point is called the point of contact. The common point of the line and the circle is known as point of contact. And the tangent is said to be touch the circle at the point of contact. Understood? The common point is known as point of contact and the tangent is touch the circle at the point of contact. Now take page 208, bottom portion of the page, theorem 10.1. The tangent at any point of a circle is perpendicular to the radius through the point of contact. Once the tangent at any point of a circle, the tangent at any point of a circle is perpendicular to the radius through the point of contact. Point of contact means the common point of the circle and the tangent. So at the point of contact, the radius and the tangent are perpendicular. So we need to prove this one. So here given a circle with the center O and radius OP and the tangent XY. Okay, we need to prove that OP is perpendicular to XY. Now first we join this O to the point Q. We can take any point on this XY line. This line say Q and join O and Q. Okay. Now look here, this Q is outside the circle, not inside the circle. Tangent, this is XY is tangent, so the Q is outside the circle. From this we can say that OQ is longer than OP. That means the OQ is greater than OP. Okay. The same way we take another point on XY, line XY and join this, that also outside the circle and that point say Z. Then OZ is also greater than OP. So we take any tangent on the circle and take a point like this, that all line segments are greater than this radius. This radius is the shortest distance from the center to the point of contact. So we can say OP is perpendicular to XY because the shortest distance from the center to the point of contact. Now in your textbook page 202 there is given of proof also. Please listen carefully. I read once. Proof. We are given a circle with the center O and a tangent xy to the circle at a point P. Given a circle, center O and a tangent at a point P. We need to prove OP is perpendicular to xy. Take a point Q on xy. Like this. Take a point Q on xy other than P and O. Other than P and join OQ, we get a like segment like this. The point Q must lie outside of the circle. Why? Note that if Q lies inside the circle, XY will become a secant and not a tangent to the circle. That means if this point is inside, means this is a secant like this. Otherwise, it cannot be inside the circle. So, this point is must outside the circle because xy is a tangent. Therefore, OQ is longer than the radius OP. So, OQ is greater than OP. Since this happens for every points on the xy except at the point P. I already told you that take any point on xy and join O and that point, we get a line segment greater than that radius. That means greater than OP. So OP is the shortest to all the distances of the point O to the point of xy. So OP is perpendicular to xy. Hence the proof. So you need to write this theorem and proof in your notebook. Now look, remarks. By the theorem above, we can also conclude that at any point on a circle, there can be only one and only one tangent. At a point, one and only one tangent. And the second remark is, the line containing the radius through the point of contact is also sometimes called the normal to the circle at the point. Another name, normal. The line containing the radius through the point of contact. The line containing the radius to the point of contact is also sometimes called the normal to the circle at the point. Normal to the circle at the point. Understood? Now exercise 10.1. Take your pencil or pen also. First question. How many tangents can a circle have? How many tangents can a circle have? Infinitely many. Right there, infinitely many. We can draw tangent like any point on the circle, isn't it? Like this. Why infinitely many? A circle have infinitely many points and so a circle have infinitely many tangent also. Next question 2. Fill in the blanks. 1. A tangent to a circle intersect it in dash point. A tangent to a circle intersect circle to 1 point. So answer is 1 point. Tangent and the circle have only one common point and they intersect at that 1 point. So answer is 1. Then question 2. A line intersecting a circle in 2 points is called a dash. I already explained in first section. A line intersecting 2 points on a circle is called a secant. Secant. Right there, secant. Then question 3. A circle can have dash parallel tangents at the most. A circle can have dash parallel tangents at the most. Now in your textbook, page number 208, figure 10.3. Look here. Here are some lines passing through the circle. How many tangents here? Here only 2 tangents, this and this. P dash, Q dash and P2 dash, Q dash. All others are secants. So how many parallel tangent? Only two parallel tangents. So write there two parallel tangents at the most. Then fourth question. The common point of a tangent to a circle and a circle is called dash. Common point to the tangent of a circle and the circle. What is the name of this point? Yes, point of contact. I already told the point of contact. Next, question 3 and 4 we will do on next class. Thank you.